wanted to record information. And I said at the time, you want to record information because this is the tools of the trade, okay? Some people have got equations, other people have got musical chords or whatever they were, we talked about at the time. You've got stratigraphic sections. And from the stratigraphic section, you've got to start to make those interpretations that we've been talking about. So on that logging sheet, you've got a width, which is proportional to grain size that we talked about.
This is the other way around, right?
Yeah. And I'll measure. And then you've got a thickness. So when you're out there, you measure, okay, I've got this much stuff, I've got 2.3 meters, and it's all fine-grained sand. So that's the 2 dimensions on there. Now Bill mentions that yours are different to what I've got up there. I've got mine this way for a particular reason, and that's because when people look at the subsurface, they usually use geophysics. They don't actually get samples of the rock that much. And so you have to have a proxy to establish what the grain size is. The proxy is gamma radiation, or gamma rays. So gamma rays are produced mainly by mud and not very much by sand. And so if you have a gamma ray profile up and down your succession, then it goes to the left if you've got sandstone, and it goes to the right if you've got mudstone. And that's why I do mine this way, because they look the same as log profiles in the subsurface. It doesn't make any difference. It's the same story. In your case, mud's over this side, coarse grain sediments are over there. The same principle. Okay, so what kind of features did you guys see? Well, here's the kind of way that you hopefully would have logged it. There's a block of a couple of meters of things that have got bidirectional ripples in them. They're obviously pretty fine grain. It's muddy, we can tell that by the width. All right. We've got a bit of bioturbation in it, not much. One of those little round blobs that were in there. Then we've got another unit. That unit's got cross bedding in it maybe, and shell lags. And so you're building up information. You're building up information on grain size. You're building up information on sedimentary structures. You're building up information on organic content. You're building up information on organic content and currents and energy. Now you've got another unit on top. This one's 4 meters of things that have got some continuous bedding in it maybe, sedimentary structure. We've got some drop stones in there. Wendenites that Bill pointed out when we were in the field. Got some hummocky cross stratification. I hope everyone remembers that and what it means. And you've got a whole bunch of bioturbation. Different bioturbation to down here. This is not much diversity and it's pretty sparse. This has got a lot of diversity and it's fairly intense. So now we're putting together lithological features, grain size, organic content, sedimentary structures. And you remember these ones, we identified bidirectional ripples were tidal in nature. The tide came in, tide went out. Gave you bidirectional ripples. The sparse bioturbation was because oxygen and salinity and food weren't great in these environments, but up here they were really good. Down here we saw hummocky cross stratification, only forms on the shore face. Here we saw drop stones, can only occur in the marine environment when you've got an iceberg going by and dropping them off. So this is the kind of stuff, and I think this is what your exercise is designed for as well in your field trip reports and that, is to get this kind of information together and make something out of it. A lot of you said when we were out there, you know, I walked over this kind of stuff before. I didn't realise there was actually interesting stuff in here. Or there was stuff that I could actually interpret and get stories out of. But it's actually there. And from it, you can say, well, this green stuff here is actually, you know, I can interpret that as estuarine sedimentation. This stuff up here I can interpret as shore face. And somewhere in between, there's got to be a transgression to get me from there to there. And I know that because I looked at my diagram of the Earth's surface and I realized that marine stuff was out in the ocean, estuarine stuff was back towards the land. To get the marine stuff on top of the estuarine stuff, I had to have a transgression. That make sense? Right, so that's how we're building up the story. All right, let's get towards the end here and say, here's an example of the clear point section that somebody else has measured, who spent a lot more time on it than you, and got a whole lot more detail out of it. But they've got grain size, thin here, and they've got the same direction as you. Thin here, so that's fine grain. Wide here, that's coarse grain, fine grain interbedded, fine grain. Bidirectional ripples, sparse biactivation, and all that kind of stuff. So, how we go about interpreting it is, well, you're all familiar with this. You remember that we interpreted that as estuarine. That was the first unit that you came to. And then, because there was a fair bit of wave energy and everything, we were a bit worried, Bill and I, about spending too much time down here. So we jumped ahead and we climbed up that first big bench there. And so that's this stuff here. That's your transgressive sand sheet. And there's your blue transgression line. There's the next shore face and marine environment. And there's your next fall of sea level. Because in order to get estuarine fill, which is the stuff here, estuarine fill over the top of that, you're going to have to get a regression. And then there's another transgression, and you're going to get a whole bunch of shore face environment that goes over the top of that. And then you can see that there's a little bit of coarsening upwards here in some of these profiles. Hopefully you saw that when you're out there. That indicates that that was prograding at the time. You got slightly coarser sediment over the top of slightly finer sediment at the bottom. Then you get another transgression, and you go into the shore face again. So it's a bit of a zigzag, another progradation. There's another transgression, another shore face, another regression, another estuary, another regression, another estuary, another transgression, and that's the Pebbly Beach formation ended, and this is the snapper point formation where we ended up looking at all the shells on the top. So I've just gone through it all and basically divided it very simply into either estuary or shore face. We can do it a lot more detailed than that, but this is, if you like, more towards the land. This is more towards the ocean. And in between, since we went backwards and forwards all these times, we've got to have these transgressions and regressions in order to accommodate that interpretation. So that's an example of a detailed stratigraphic log. If you spent maybe a week or so in the field there every day, that's the sort of thing that you'd come up with. And they're the kind of interpretations. And just to jog your memory, there's an example of what it looked like. There's that first unit down there. There's the estuarine stuff with the little bidirectional ripples and not much biactivation. There's where we got the transgression going through, right through here. And this unit is that cross-bedded. You can see all the big cross-beds in there. That's that transgressive lag and marine sand when the shoreline passed through. And that's the example of the detail of the stuff that we saw down there. And then if we go up and contrast that with some of the shore face stuff, there's some of those continuous units that represent these things in through here. There's a big drop stone in the middle, in through there. And so this is our kind of lower shore face environment. And you can see that this stuff here is really different to this stuff here. Okay, here's a thought exercise for you. You've listened to all that, nodded off occasionally and sort of concentrated at other times. But now comes the critical point, okay? So we're going to apply what we learned a little bit if you're in a real sort of job situation. So you graduate, you've done this course, you're great sedimentologists and stratigraphers, you get employed by, I don't know, Oil Search or somebody like that, who's got their office in Sydney. You might have heard of them in the news at the moment. The big earthquake in New Guinea just took place. Oil Search is doing all the transportation of materials backwards and forwards. Anybody seen any of the stuff on TV of the landslides and things in New Guinea at all? Yeah, in the news? It really there's thousands of landslides all over the place. I only mention it because keep it in mind when you think of the site that we saw initially where the unconformity was, day 2. Yeah. Myrtle Beach unconformity. Remember those great big units that were all poorly organised and we identified them as probably debris flows and things?
That's waste.
And we talked about maybe they were formed by earthquakes. Well, that's exactly what happened in New Guinea in the last couple of days, and those hundreds and hundreds of landslides and deposits be very similar to the ones that you saw at Myrtle Beach. Anyway, by the by, here's your job situation. You just got employed, you're the expert in that location, and there's some data's come in. There's been a block available here, and you had 9 drill holes had been put in there. And so your boss comes up and says, look, there's a lease sale going on. People want to actually put some leases out around that area there, and they want us to bid for it, money. And that can go anything from a on-land block where you might bid $1 million, for example, to an offshore block in the Gulf of Mexico. You'd bid $1 billion for one of those blocks. That's a lot of money. So in doing that, you'd better make a good decision. So if you've just been employed, they probably don't give you the deep water Gulf of Mexico, but they probably give you the onshore story. So here's what the boreholes actually had in them, okay? These ones here with the green colour were shore face deposits that were interpreted. Those ones there with that colour, with the O, they're offshore marine deposits. These ones, the E behind, so you went in there, you analysed the core or the logs that they got out of those units, and now your job is to say which blocks are we going to bid on and how much money are we going to pay for them. So which blocks are you going to bid on?
7 and 3.
What do we want? 2, 3.
7 and 3. Anybody got different ideas?
You want this? You want the S ones? Why do you want those things?
Why do you want the S ones?
Yeah.
Well, there's a good question. Because they're green. Okay, so in the first instance, because they already proved to have oil in them, because the green dots are oil and the red ones are no oil. And secondly, because in general, offshore muds aren't good reservoirs, they don't have good porosity and permeability. We'll talk about that in a minute. And nor do the estuarine muds that we looked at before. So you want sandy deposits with relatively coarse grains that have got lots of porosity and space in them. And so they're shore faces, they're good.
Which way is it going? Is it regressing?
We don't know that, obviously. But if it's a shore face, then it's probably regressing a little bit. So that might come into consideration, depending on how many blocks you bid for and how much money you've got. So anyway, I think we don't want to stay here too long. That's our interpreted shoreline and shore face. Okay, so you're absolutely right. You want 3 and 7. You don't want 6, 8 or 9. You don't want the estuary block in the back part, and you don't want 1, 2 and 4. But that's a good observation to say which way is it going. Being a short face, maybe it prograded this way a little bit, but we already know that it didn't quite get to there. So that might give us an idea of dimensions. And so the next job is, your job at the company is not just to say, okay, let's get 3 and 7, we'll break out the champagne and go and have dinner on the company or something like that. The next job is to say, well, how much money are we going to make out of this? And so, who's got a calculator? All right. So here's your story. This is 4.5 kilometres from end to end, 4,500 metres. Won't want to write down the numbers anyway and do the calculations yourself later if you haven't got a calculator. 4,500 metres. That's the distance from Merriweather Bars to Nobbies. Okay, that's how big that shore face is. 300. Well, it's not that huge. Comment down here, well, it's huge, but think of Stockton Beach. Okay, goes from Nobbies to Port Stephens. It's 30 kilometres long. So that's 6 times longer than that one. Or the one at Tuncurry. It's about 10, 12 kilometres long. So not an unreasonable size for a feature. It's 300 metres wide. These are 1 kilometre blocks. So you've got 4.5 kilometres, 4,500 metres. You've got 300 metres wide. And if we go back to here, let's just say this unit here is the reservoir. It's the coarsest grained unit. It's got the best porosity. This is the unit that we're searching for. It's 2 metres thick. So there's your volume. Okay? 4,500 metres long, 300 metres wide, 2 metres thick.
2.7 cubic kilometres.
Okay? So there it is. 2.7 cubic, 2,700,000 cubic metres. That's the volume. Now we've got to get the porosity. What's the likely porosity of some Permian sandstone that's been buried there for a couple of 100 million years? 5, 10, 50% porosity. That's a question of how much space is there in the rock. 5 or 10? Anybody got other ideas?
2%?
Could be as low as 2, but we wouldn't be very interested in it if it was as low as 2. But it definitely could be. Could be 5 or 10. It's unlikely to be 30, 40, 50. That's the initial porosity of those kind of rocks when they're deposited. So let's say 10. Okay? So 10% of that volume is space that can be filled with oil. So that's 270,000 cubic metres. So now we've got to convert that to barrels of oil. There's about 6 barrels in a cubic metre. So now we've got 1.7 million barrels of oil. What's the price of oil these days? You want to know? A barrel. 1, 5, 10, 100.
700 a barrel or something?
60.
60 bucks.
$60 a barrel. So you got $100 million worth of oil in your reservoir. So that's basically the end of the story on this. You were given the task, the new sedimentologist in the company, you were given the task of interpreting the 9 boreholes, figuring out what lease blocks to buy, and then going to the engineer and saying to him, look, on the basis of the volumetrics, I can tell you approximately how much sand is there in the reservoir. I can estimate the porosity from the log data, and from the porosity, I can estimate the economics for you. So you can go forward now and figure out, is $100 million enough for us to invest in? You got all of that from the simple stuff that we just talked about. Okay, end of the story. What you did, and this is what you got. Okay, at the end of the day, you found out that most of what you saw at Clear Point in Pebbly Beach was estuarine and shallow marine sedimentation. When you went there, you didn't know any of this. When you went away, you knew all of this. Okay? You knew the grain size, you used that, you used sedimentary structures, you used the trace fossils, and the fossils, the shell content, to help you in those interpretations. You interpreted that there were multiple shoreline transgressions and regressions. In order to go up and down through that stuff, you had to have at least tens of meters of sea level change. We found that multiple fin sequences, so we had about half a dozen in 20 meters or so. So each one was only 2 or 3 meters thick. And when you interpret all that together, you can say down there on the south coast in the early Permian, it was an ice house environment. And you had those little thin sequences were the things that were produced, and by analogy, very similar to the ones produced in the last ice house intervals, the last 250,000 years in our area, up in places like Foster and Tuncurry. End of story.
Questions? I've got a question. Tom said that mine emitted more gamma rays than sand. Why is that? What's in mud? What's one of the major components of mud?
Material.
Yeah, but it's got to be a radioactive thing, so what is it?
Yeah, why is mud? What's one of the major components of mud other than silt?
What about the little creatures that...
No, there's two size components to mud. One of them's silt, and the other one's, you got it in the diagram in the booklet. Clay, thank you. What's in clay? Well, yeah, what is not normally radioactive? What sort of clay minerals do you know?
Phosphate?
Well, they're weathered feldspars, essentially. What elements do you know that are radioactive?
You just took credit for my answer.
Saying it properly. She was like, potassium, Renee.
It's alright, I'll give a go.
Yeah, no, give it to her. I'm not taking credit for it.
Is that called mansplaining?
Yes, it is, actually. Didn't someone get accused of that in government?
So yeah, well, one of the clay minerals, well, one of the main ones is kaolin, but there's also a thing called illite, which has a lot of potassium, and potassium tends to adhere to clay. And there's a significant amount of potassium in potassium-40, which is radioactive. So there you go. I think we all should thank Ron for coming on today. We didn't pay him.
Thanks, Ron.